So another exciting use of the exchange method in Walter Nepp's book is to find the inverses of matrices. And of course, I'm sure for any of you watching this video, you guys probably learned how to use the row methods to do that, the Gauss elimination methods. But I also think that this is so nice and it's so elegant to look at it this way. And of course, as you all know, and as he points out on page 102, is he says, well, if we have some set of equations, let's say his notation is Fi is equal to the summation, let's say, of k equals 1 through n of the aik ek, right? In other words, he says, if you have f equals to the matrix A times the vector E, then the inverse matrix, when you apply it to both sides, will give you A inverse of F will equal to A inverse times A, which will be the identity matrix, times E. So we'll have E. And so somehow, not somehow, but basically what he's saying is, this is the expression represented here, which we know can be represented by an exchange tableau like this, E1, E2, En, because there's n of them. And then here, F1 all the way up until how many i's are there? Here he's claiming that there's n of them. Of course, that makes sense because we can only invert square matrices, okay? Okay, and of course here it would be A11, ANN, A1N, wait, what? I'm sorry, N1, and then, right? And of course, these would all be filled in. And so this would represent this original system. But you can see that if I write this down, and I can just rewrite it like this, E equals to A inverse of F, from the way it's located, from the way it's written, you can see that I could express this relationship using an exchange tableau where the E1 has been flipped with the F1, the E2 with the F2, and so on, because then that would be what would be represented here, right? In other words, this matrix relationship can be expressed as F1 all the way to Fn, E1 all the way to En, and of course the corresponding coefficients would go on the inside. And so basically you can already see what's going to happen. All we do is, if we want to find the inverse of, let's say the matrix A equals 1, 2, 3, 4, 7, 6, 2, 7, 6. All we do is we make the exchange tableau and we exchange out all the variables. And so now let's do that together, and so that we can all be filled with joy. Yes. So we have this matrix. Okay, we want to find its inverse. So we can just imagine, for our own benefit, that this is E1, E2, E3, and this is F1, F2, F3, and then I've copied this in 1, 2, 3, 4, 7, 6, 2, 7, 6. And I want to begin with this pivot so I can exchange the E1 with the F1. So now that we know how to do this exchange steps, this will be straightforward. Well, it'll be sort of straightforward. But I hope you'll agree with me that when you see it this way once, like, it shows you the inherent validity, well, not the validity, but it shows you the inherent conciseness of this technique. So, for example, I've identified this as my pivot element. So I'm going to put a star there in the cellar row as a placeholder. Basically, it doesn't have to be there. It can just be empty. Then, for the rest of the cellar row, we take the rest of the pivotal row, we divide it by the pivot. So what's 2 divided by 1? That's 2. And then we multiply by negative 1. So it'll be negative 2. What's 3 divided by 1? 3. And then we multiply by negative 1, which gives us negative 3. Okay. Now, once we're here, we can proceed to the next exchange tableau, which is going to have the F1 going here. The E1 is going to go here because those are going to have been exchanged. And then the rest of it is going to stay as is. Okay. Like this. Okay. We're going to leave our center row there because we're going to perform another exchange in a moment. But now let us complete this first exchange. So first of all, I'm going to replace the pivot element with its reciprocal. What's the reciprocal of 1? Well, I can write 1 as 1 over 1, and if I take the reciprocal of that, I also get 1 over 1. So in fact, in this case, it just stays as 1. I replace the rest of the pivotal row in the new tableau with the rest of the cellar row. In this case, negative 2, negative 3. I replace the rest of the pivotal column in the new exchange tableau with the pivotal column elements divided by the pivot. 4 divided by 1 is 4. 2 divided by 1 is 2. Okay? And now, if you'll notice, what's going to happen to these? Right? That's where the kind of, that's where the magic comes in. No, I'm just kidding. But so basically, we're going to take the corresponding members of the pivotal column and the cellar row. We're going to multiply them. So for example, what's going to take this place in the new tableau? Well, it'll be negative 2 times 4, which is negative 8. I'm going to add that to 7, and that gives me negative 1. Okay. What about this one? It'll be the negative 3 times 4, which is negative 12, plus 6, negative 6. What about this one? This one? Negative 2 times 2, that's negative 4, plus 7, that's 3. And then finally, what about this place here? Negative 3 times 2, that's negative 6, plus 6 is 0. So like, I mean, how do you call it? Like, I think this is so cool. Okay, I gotta be honest with you. So now, let us proceed to the next exchange we need to perform. First of all, we can see this is not 0, so we can actually perform the pivoting operation. In other words, we can exchange the E2 and F2, and that's going to be our next goal here. Okay, so what I can do is I can identify it as my pivot by circling it. And then what I'm going to do is I'm going to make my cellar row to prepare us for the exchange step. So I'm going to put a star there just to indicate that there's nothing there. Okay. And then what I'm going to do is I'm going to divide each member of the pivotal row by the pivot and then multiply by negative 1. So what's 4 divided by negative 1? Negative 4. Times negative 1? 4. What's negative 6 divided by negative 1? Positive 6. Times negative 1? Negative 6. By the way, it doesn't always work out that way, obviously, that the cellar row looks identical to the pivotal row. Okay, so you can see here, of course, the sign's changed. And, you know, of course, you'll see later that, right, it was just, I don't want to say it was just chance, but it was kind of just chance that this was a 1, this was a negative 1. Obviously, if it had been 2, 3, whatever, these would not have been like 4 and 6. It would have been something else. But anyway, let's continue. So now, once we have prepared our cellar row, we are prepared to write the next step in the exchange. Okay. So once I have by the way, before we continue, notice what could have happened here. If I wanted to, I could write out these equations, and I could write down E1 equals F1 minus 2E2 minus 3E3. F2 is equal to 4F1 minus E2 minus 6E3. F3 equals to 2F1 plus 3E2. Okay? Okay, anyway. So now, let's continue, right? In this new exchange tableau, I'm going to keep the F1, but but I'm going to have exchanged the F2 with the E2, and the E3 is still as yet to be changed. And then here, the E1 will not have been exchanged because we already exchanged it. This will become an E2 now because we will have exchanged it, and the F3 will remain here for the time being, right? And now we are prepared to write down the consequence of what we've just done. So first of all, I'm going to replace the pivot element in the new tableau by the reciprocal. In this case, the reciprocal of -1 is -1. Okay, so that will go here. The rest of the pivotal row is replaced by the cellar row. So in this case, it stays the same, believe it or not, right? And then the rest of the pivotal column is replaced by the elements of the column divided by the pivot element. So -2 divided by -1 is +2. The 3 divided by -1 is -3. Okay? And then the remaining members of the new tableau that represents this exchange, we get them by multiplying the corresponding members of the pivotal column and the cellar row and adding it to the coefficient that is there. So for example, here, 4 times -2 is -8 plus 1 is -7. And then what about this bottom corner? 4 times 3 is 12 plus 2 is 14. What about this upper right hand corner? That's going to be -6 times -2, which is +12, minus 3, that's 9. And then this bottom right hand corner would be -6 times 3 is -18, plus 0 is -18. Okay. So if you notice now, the only exchange that's left for us to perform in order to get the final exchange tableau is to exchange the E3 with the F3. And you can see here that in fact, since it's a -18, we will in fact be able to do the exchange. If it had been 0, we would have been stuck. Okay. So I'm going to use this as my pivot element. And so if you notice, of course, what goes below the pivot element? Just the space, which we represent with a star as a kind of placeholder. Then for each of these elements for the rest of the cellar row, we take the rest of the pivotal row, we divide it by the pivot and multiply it by -1. So let's say -3. -3 divided by -18 is +3 divided by 18, which is +1/6. And then I multiply by -1, which is -1/6. Then what about the 14 divided by -18? That's going to be -14/18, which is -7/9. I multiply by -1, I get +7/9. Okay. And so now we're finally in position to do the final exchange tableau that'll give us the inverse. Okay, so let me do that one up here so we don't lose any of our beautiful exchange tableaus. One of the things I want you to notice here is how little space this takes up. Okay, it's a very nice technique in that regard. It's very concise in the space it holds, and it's very clean in its execution. Now, of course, we will need to do some scratch work on the side over there, on the side of the board there, but you can see that overall it's a very compact and nice way of performing this calculation. Okay, so now let's begin. So first of all, we're going to replace the pivot in the prior tableau with its reciprocal. In this case, it'll be -1/18. Okay. We're going to replace the rest of the cellar row by the members of the rest of the pivotal row by the cellar row. So in this case, 7/9 and -1/6. The rest of the pivotal column will be replaced by the coefficient divided by the pivot. So 9 divided by -18 is negative 1/2. Negative 6 divided by negative 18 is positive 1/3. And then, of course, this part will be performed using what I showed you earlier. The corresponding member of the cellar row times the corresponding member of the pivotal column multiplied, then added to the coefficient that's in there. So, for example, what happens to this negative? What happens to what goes in this space in this final exchange tableau? Well, it'll be 7/9 times 9. Wow, that actually works out very nice. That actually gives us 7 plus negative 7, 0. What happens in the second space? Well, it'll be negative 1/6 times 9, which is negative 3/2 plus 2. 2 is the same thing as 4/2. So negative 3/2 plus 4/2 is 1/2. Let me double check that, please, before my brain melts. So negative 9/6 plus 2/1. Multiply that by 2 on the top and bottom. I simplify this, divide by 3, divide by 3. Negative 3/2 plus 4/2. Oh yeah, it works. It's positive 1/2. That's right. What goes here? Well, it'll be the 7/9 times negative 6 plus 4. So that'll give us, so if I want to multiply these two first, that'll be negative 42/9, right? Or you can even, yeah, let's do that together. So that'll be negative 42/9 plus 4. And let's say 4/1, because we're going to want to get a common denominator. Now, you can see that this can be divided by 3. And so we're going to end up with a 3 on the bottom. So I'm just going to preemptively multiply this one with a 3 on top and bottom. So this is going to be negative on top. Negative. What's 42 divided by 3? That's going to be 14. So it'll be 14/3. And then plus 4 times 3, that's 12/3. So it'll be negative 2/3. By the way, just so you can see that real quickly here, if I put 3 into 42, 3 goes into 4 ones. 1 times 3 is 3. 4 minus 3 is 1. I bring down the 2. 3 goes into 12 4 times. 4 times 3 is 12. And you can see that the remainder is 0. Right? So that's how I knew that when I divided the 42 by 3, I got 14. So dividing the top and bottom by 3, I got 14/3. And that made it easy to do the calculation there. Now finally, as you can see, we're about to finish this calculation, which will fill us with great joy and wonder. And, well, it won't fill us with joy and wonder, but it'll be a very nice display of this technique. So finally, we want to find out what goes here. So it'll be the negative 6 times the negative 1/6, right? The corresponding members of the cellar row and the pivotal column. So that'll be positive 1 plus negative 1. That's 0. Okay. And how do you call it? And so now, after all this, our claim is that the inverse of this matrix, our A inverse is equal to 0, 1/2, negative 1/2, negative 2/3, 7/9, negative 1/6, negative 1/18, 0, and then 1/3. Okay? Because you can see that what we've done here is we've expressed, if we wanted to rewrite this as a system of equations, we would say E1 equals to 1/2 F2 minus 1/2 F3. E2 is equal to negative 2/3 F1 plus 1/3 F3. And then, of course, E3 is equal to 7/9 F1 minus 1/6 F2 minus 1/18 F3. Okay? Okay, let me write that down explicitly just for concreteness. Okay. So that's what this system gives us. But so now we want to find out, is this actually the inverse? So let's do that together. So of course the only way to find out if you actually got the inverse is to bargain. Please do the inverse. No, I'm just kidding. That's just a joke. No, it's to perform the matrix multiplication and to see if we end up with the identity matrix. Okay. Of course, the identity matrix is just the matrix with zeros everywhere except the diagonal and ones across the diagonal. Ones on the diagonal across the whole thing, across the whole diagonal. So let's perform this matrix multiplication together. Okay. 1 times 0 will give us 0. 2 times negative 2/3 will be negative 4/3. And then it'll be plus 3 times 7/9. That'll be 21/9, or if I divide the top and bottom by 3, 7/3. Like this. Okay? Then 1 times 1/2, that'll be 1/2. Plus 0, plus negative 3 times 1/6, or in other words, minus 3/6, which is minus 1/2. Then, finally, negative 1 times negative 1/2 is negative 1/2. Plus 2/3. Plus negative 3/18, or in other words, minus 3/18, minus 1/6. Okay. Then I'm going to perform the multiplication across the second row and to get the second row of the product matrix. 4 times 0, I don't have to write that because that's 0, plus 7 times negative 2/3, which will be minus 14/3, plus 6 times 7/9, that's plus 42/9, which is plus 14/3. We know, so of course, so let me just walk you through that. So I saw that this was basically plus 42/9. And we just saw in the previous problem that 42 divided by 3 was 14. 9 divided by 3 is 3. So we get 14/3. Here, 4 times 1/2, that's 2. Plus 0, minus 1. You see 6 times 1/6 is 1. But it's plus minus, so it's minus 1. Okay? Then, finally, 4 times negative 1/2 is negative 2. Plus 7/3. Minus 6/18, or minus 1/3. Okay? Finally, 2 times 0, 0. Plus negative 14/3, or in other words, minus 14/3, plus 42/9, or 14/3. Then here, 2 times 1/2, that's 1. Plus 7 times 0, that's gone, because 7 times 0 is 0. Plus negative 6/6, in other words, minus 6/6, which is minus 1. Finally, 2 times negative 1/2, that's negative 1. 7 times 1/3, that's going to be plus 7/3. And then finally, plus negative 6/18, which is minus 6/18, which is minus 1/3. Okay? Okay, so let's look at what the cat brought in, okay? Or let's just solve this, or simplify it. So negative 4/3 plus 7/3 is 3/3. What's 3/3? It's exactly 1. What's 1/2 minus 1/2? 14, right? No, I'm just kidding. 0. I know what all of you thought right there when I said 14. That is obviously wrong. There must have been a microchip in his brain that fried. It's obviously defective. This is a new pathology. No, I'm just kidding. Now, okay, now here it's more interesting. Well, it's not really more interesting, but we can pretend it is. So I can calculate this as follows. Negative 1/2 plus 2/3 minus 1/6 I can multiply the top and bottom of this one by 3. So it'll be negative 3 over 6 plus, I can multiply the top and bottom of this one by 2 over 2. So it'll be 4 over 6 minus 1 over 6. So negative 3 6 plus 4 6 is 1 6 minus 1 6. That one becomes 0. Right? Negative 14 plus 14, negative 14 thirds plus 14 thirds, that's 0. 2 minus 1, 1. Negative 2 plus 7 thirds minus 1 third. I can see that 6 divided by 3 is 2, right? So this is negative 6 thirds plus 7 thirds is 1 third. Minus 1 third, 0. Like that. Negative 14 plus 14, negative 14 thirds plus 14 thirds, that's again 0. 1 minus 1, that's also 0, right? What about this one? I can see that negative 1 is the same thing as negative 3 over 3 plus 7 over 3, that's 4 thirds. Minus 1 third, that's 3 thirds, which is again 1. And so what does that tell us? That tells us that this is in fact our inverse matrix for this one. And we found it using the exchange method. I hope you all have enjoyed this, and I look forward to seeing you again. Thank you.